Good morning, everyone. My name is Justine Johnson, and I'm a Community Engagement Manager at the BC Energy Regulator. Today, I have the opportunity to chat with James Gladys, Facilities Engineer, Jordan Van Bassau, Drilling and Production Supervisor, and Christopher Sirianis, Air Emissions Scientist, about some of the most asked questions about flaring and air quality. This conversation is available with closed captioning. To activate, please click on the CC at the bottom of your screen. Before we get started, we'd like to acknowledge the many First Nations, each with unique cultures, languages, legal traditions, and relationships to the land and water on whose two territories the BCER's work spans. Today, our team is going to be answering some of the most asked questions we've collected over the last few years. Specifically, we're going to be talking about what flaring is, why it's necessary, some of the regulations and guidelines associated with flaring at well sites and facilities, and how we monitor air quality. So to get us started, the first question is, what is flaring?
So flaring is just the controlled burning of a waste gas stream that cannot be processed or otherwise sold or used. It typically ends up as a result of non-routine situations such as maintenance activities or process upsets at a well or facility. The waste gas is ignited at the end of a long metal pipe with engineered components known as the flare stack. And it's this ignition at the end of the flare stack that causes the characteristic flame that is associated with flaring.
And why is flaring necessary?
Fundamentally, it's a safety measure. It's used to dispose of a waste gas stream at a facility if there's a facility upset, as one example, and doing this prevents a situation from turning into a bona fide emergency. It's also better than releasing the gas to the atmosphere directly, known as venting, because it results in fewer greenhouse gas emissions and reduced pollution compared to venting. Fundamentally, it's a safe way to destruct natural gas and other hydrocarbons at well and facility sites.
How does the BCER regulate flaring emissions?
The BCER regulates the entire life cycle of oil and gas, methanol, hydrogen, and geothermal activities through the Energy Resource Activities Act. There are a number of regulations under ERA that document the requirements for flaring. The drilling and production regulation is for wells and includes drilling, completions, and operations. The oil and gas processing facilities regulation is for gas plants, refineries, and manufacturing plants that convert natural gas to other products. The liquefied natural gas facility regulation is for LNG facilities for both domestic and export-based projects. For larger projects, such as LNG plants, gas plants, compressor stations, there is a specified enactment in ERA that gives the BCER authority to grant waste discharge authorizations or permits under the Environmental Management Act. If a flare stack was authorized under an EMA permit, then the BCER can impose conditions on flaring, such as restrictions on flow rates and emissions, and reporting requirements.
Are there requirements in place to ensure flaring is done safely?
Yes, in BC, we have a number of requirements in place to ensure flaring is carried out in a safe manner. First of all, the flare system design and operations are required to have adequate oversight by a professional engineer registered with Engineers and Geoscientists BC. Second, industry is accountable to have trained personnel regularly monitor ongoing flaring activities to ensure compliance with regulations. These requirements, combined with risk-based BCER site inspections and facility integrity management audits, provide a level of safety related to flaring. The BCER also issues site-specific air discharge permits under the Environmental Management Act for large oil and gas and liquefied natural gas facility operations. Each permit contains requirements for limiting the release of air contaminants such as sulfur dioxide, nitrogen oxides, and carbon monoxide. Requirements to limit air contaminants for smaller operations are specified in the Oil and Gas Waste Reg and the Drilling and Production Regulation.
And what resources are available for industry?
Yes, Chris listed the various regulations in a previous slide that apply to activities where flaring may take place. We also have a dedicated published guideline on our website called the Flaring and Venting Reduction Guideline that describes in detail the regulatory requirements for all types of flaring and how those requirements can be met. There are decision trees within the guideline outlining when flaring is appropriate and where other measures to conserve natural gas are to be taken.
When can permit holders flare at a well?
It's a good question. And the regulation contemplates a couple of different situations where a permit holder might be able to flare at a well. And the first is that they may flare at a well if it's required for emergency purposes or for drilling operations. So for instance, if while drilling an overpressured formation is encountered, the permit holder might flare that gas off when it's circulated to surface to dispose of it safely. They may also flare intentionally at a well that's being drilled underbalanced. A second situation where permit holders can flare is at a well, but for workover or maintenance purposes, limited to no more than 50,000 cubic meters of gas per year. So for instance, they may flare gas for a very short period of time when unloading a well with nitrogen prior to returning the well to regular production. And finally, permit holders may flare gas at a well where there's a specific permission in the well permit to do so. This is commonly done for modern Montney wells, where the wells are authorized to flare up to a certain amount of gas for the purposes of well cleanup and testing. Now, there is still a requirement for permit holders to test their wells in line to a pipeline as much as possible. But in spite of that, some flaring is typically still required for very small periods of time to allow the wells to reach pipeline spec where the gas can safely be introduced into the pipeline.
Do facilities always need to have a flare?
Yeah, this is a question we often receive. Facilities do not always require a flare system. The decision to include a flare system in a facility design is made by the permit holder based on a combination of the risks associated with the actual specific facility and the regulatory requirements for safe operation. For example, if sour gas is handled at a facility and there is also a compression or dehydration equipment in place, a flare system is typically required to safely burn the sour gas emitted in both routine and non-routine scenarios. And all proposed designs are reviewed by BCER engineering staff to ensure compliance with the regulations for safe operation.
What alternatives are there to flaring?
Yes, there are a number of alternatives, and we'll discuss three of those here today for facilities. The first option is to not include a flare system in the facility design. Small-scale facilities, such as those at well sites, often do not require flare systems where the design and equipment are simplified, and there's a very low risk of an unplanned product release. A second option is incineration. This is sometimes used to burn a continuous low-pressure gas waste stream and eliminate a visible flame, but requires a significant volume of additional fuel gas to operate, making it often costly and inefficient. A third option is to capture and recover waste gas volumes with dedicated compression equipment. This is the most favorable method to reduce flaring at larger facilities and has become a standard in all of our new gas plant designs. Also, many older facilities have been retrofitted with vapor recovery units to reduce flaring.
What does proper combustion at a flare stack look like? Is visible flame okay?
Safe and sufficient combustion at a flare stack takes place when there is adequate airflow mixed with the waste product to be burned. And the result is a flame that is visible and usually bright yellow-orange in color. And there should be very little or no visible plume beyond the flame. Many flare systems are equipped with a continuous small pilot flame, which again would be visible, which helps ensure waste gases are reliably combusted when required.
What about black smoke? Is it a problem?
Black smoke results from poor combustion, and it can contain particulate matter, unburned hydrocarbons, and other products of incomplete combustion, such as polycyclic aromatic hydrocarbons, or PAHs for short. BCER regulations require permit holders to design facilities to ensure good combustion whilst flaring. Black smoke can be reduced from flares by adjusting the operating characteristics or by modifying the design of the flare system. Air, gas, or steam-assisted flares are currently used at some of the larger gas processing plants and LNG plants to improve combustion efficiency. The oil and gas processing facility regulation requires permit holders to ensure there is no black smoke during routine flaring and minimal black smoke during non-routine flaring. Minimal black smoke is defined as periods not to exceed a total of 5 minutes during any 2 consecutive hours. The drilling and production regulation has a similar requirement. If black smoke is observed at a flare, the operator and/or the BCER should be notified so that potential corrective action can be taken.
So here are some flaring examples. What exactly am I looking at here?
Okay, determining the acceptability of a flare's performance in reference to our regulations is a challenging endeavor. So we'll show you a couple examples here, and these are snapshots in time, and on their own can't be used to reliably judge the adequacy of combustion over an entire flare event. Information on the duration, flow rates, gas compositions, reasons for flaring, and video would be needed to properly judge a flare event. For the examples we see here, the one on the left is ideal with no visible emissions. When flaring is required, we strive for situations like this. The figure on the right is not necessarily ideal, but we would need more information on the event to properly adjudicate.
And what about these examples?
The example on the left, again, is not ideal. If indicative of the entire event, compliance and enforcement action may be in order, but depending on the circumstances. The figure on the right shows a slight gray visible plume beyond the flame. And although it is likely not a serious issue, we would need more information on the event to properly judge it.
How are flare emissions measured?
Yes, flared gas volumes are recorded using specialized measurement equipment at facilities and during the testing of wells where there is a continuous flow of gas to the flare system. These volumes are reported to the BCR along with all routine and non-routine flare events that exceed a specific volume stated in regulation. The emissions from flare combustion are more challenging to measure and are calculated using emission factors and gas composition where possible. Innovative camera designs are also used by industry and the BCR to monitor flare emissions at a point in time to check flare performance and efficiency. The BCER relies on flare performance regulations to ensure flaring is done safely and pollutant emissions are minimized.
How does the BCER monitor the impacts from flaring in the environment?
The BCER has 2 main ambient air quality monitoring units. The Continuous Air Monitoring Environmental Laboratory, or CAML, that you can see in action in the picture on the slide. And we also have the Roaming Air Monitor, or RAM. The CAML is a trailer, as you can see there, containing the equipment to continuously monitor a wide range of air pollutants and meteorology. It is designed for long-term deployments from months to years. The RAM is a specially designed van housing equipment to continuously monitor air pollutants while driven or parked. It serves as a quick response unit for emergencies, but also can be used for other short-term ambient monitoring deployments when not in emergency service. For example, the RAM was recently deployed to Kitimat for the commissioning of LNG Canada. It is important to note that the gas analyzers are interchangeable between the CAML and the RAM, allowing flexibility when preparing deployments. We also have 2 portable air monitors the size of small suitcases that can be quickly deployed in response to incidents and complaints. In addition to our monitoring capability, there are 14 continuous ambient air air monitoring stations in northeastern BC, measuring a wide suite of pollutants, some of which are located where oil and gas activity is prevalent. The monitors are either run by the province or by industry as a condition of their permits under the Environmental Management Act. The BCER supports the operation of one of these stations, the Farmington Station. The data collected at these stations are available on the province's website in real time and available for downloading for historical events. The Regulator Air Tool is a web-based mapping tool that we have that shows the location of CAML deployments over the years and summaries of the data that's been collected. Also on the mapping tool, we have the locations of air permits and registrations that are issued by the BCER under the Environmental Management Act.
What factors affect a flare's performance?
A flare's performance will depend on a number of factors. First one I'd like to talk about is gas composition. So the more light hydrocarbons, such as methane and ethane, that are in the gas, a better performing flare is likely. Heating value of the gas is related to gas composition. Low heating values usually indicate higher compositions of inert gases, such as carbon dioxide or nitrogen. Lower heating values can lead to poorer performing flares. Exit velocities are another factor that can affect the flare's performance. Flares should be designed to handle the expected flow rates. Under-designed flares, where the diameter is too small, can lead to noise problems from higher exit velocities, while over-designed flare stacks, where the diameter is too big, can lead to poorer performing flares from exit velocities that are too low. Meteorology can also affect a flare's performance, and this is related to exit velocities. High wind speeds can decrease flare performance, and especially under low exit velocities. And finally, flare tip design. Combustion is very complex, and flares need to be designed for the expected gas compositions and flow rates. Air, gas, and steam-assisted flares can be utilized to improve combustion, and these are usually found at larger plants, gas processing plants, and LNG facilities.
What is exactly emitted from flares?
So flaring is a form of combustion, and as such, emissions from flaring are similar to any combustion source. Flaring will mainly emit water vapor and carbon dioxide, and other trace amounts of pollutants like oxides of nitrogen and carbon monoxide will also be emitted. If the gas being burned contains sulfur compounds like hydrogen sulfide, then sulfur dioxide will be emitted. As well, unburnt gas, particulate matter, PAHs, as I spoke of earlier, can also be emitted, and the amounts will be dependent on the performance of a flare.
What about flaring sour gas? Is it a risk to the public?
Sour gas is defined by the hydrogen sulfide content of the gas. When H2S is combusted, it is oxidized to sulfur dioxide. At the design phase of a facility, air dispersion modeling is typically done, usually for the main hazard, sulfur dioxide, and when the H2S content is greater than 1%. And this is to ensure that potential flare emissions will not be harmful to people or the environment.
Temporary flaring at well sites, for example, during well cleanup and testing, is assessed similarly, with dispersion modeling requirements kicking in at that 1% H2S content.
And to manage risks to the public, the regulations state that where a facility could flare sweet or sour gas and does not have on-site personnel supervision 24 hours a day, the design must include an adequate auto-ignition system. This ensures that gas flowing from a flare stack is always being safely burned. In addition, for sweet gas flaring, the flare stack is required to have a continuous monitoring device that detects the presence of a flame, or the flare is inspected at least every 7 days. For continuous flaring of sour gas, a flameout detection device must be installed on the flare stack with the capability of shutting down the facility and providing an immediate alarm to the permit holder. As stated earlier, the BCER reviews the engineering design of all new facilities and any major changes to facilities to ensure the design is acceptable. We also complete pre-startup inspections of most sour facilities to ensure readiness for safe operation and periodic operational inspections during the life of the facility.
And lastly, how does the BCR know emissions from a flare stack are safe?
Safe isn't a technical measurement, and it can mean different things to different people. In our view, permit holders are required to design and operate their wells and facilities in accordance with BCER regulations and other applicable codes and standards, and as well as guidance from us. And that includes specific equipment, such as flares. The BCER uses the design phase review, inspections, compliant and enforcement endeavors to ensure permit holders are following the intent of the regulations. In the instances where permit holders are non-compliant with our regulations, the BCER can enforce penalties and require permit holders to come into compliance with regulations before continuing operations. Where the design and operation of a facility meets or exceeds the regulatory requirements, the BCER would consider the risk associated with these operations to be as low as reasonably practicable.
And those are all the questions we have for today. Thank you, James, Jordan, and Christopher, for taking the time to walk us through this information. If you have any further questions, please email us at communityengagement@bc-er.ca. Thank you for joining us.